This question is about infrared spectroscopy. Compounds A and B both have the molecular formula C4H8O2. Figure 1 shows the infrared spectra of compounds A and B. Use the infrared spectra to deduce a possible structural formula for compound A and a possible structural formula for compound B. So we need to have a look at table A on the datasheet, which I've just pulled in here. And if you have a look, remembering that we can cross out the fingerprint region if we're using table A. So I'm just going to cross that bit out. What we've got here, this is 16, 17, 18. So we're looking at a C double bond O peak here. And here we've got an OH in alcohols. This is like, it looks a bit like a finger between 3,200 and 3,500. This is the CH peak. And then our second spectra, again we've got that section that we can just ignore. Here between 16 and 17, if we have a look at our, let's bring that down a bit so we can see it. Between the 16 and 17, that's an alkene peak, and this is still an OH in alcohols. So compound A has an OH alcohol and a C double bond O, and compound B has an OH alcohol and a C double bond C. And they're both, if we remember, if we go back up, both C4H8O2. Okay, so the formula shows that there's a double bond somewhere, and in our structure A we know that we have a C double bond O. So anything that is going to have a C double bond O in it, so we need any structure that contains a C double bond O and an OH, but that is not a carboxylic acid. So there's going to be an awful lot of possible right answers here. But we've got 4 carbons, we could put a double bond O on and an OH, and it really doesn't matter where you put them as long as you don't do a carboxylic acid. So as long as you don't do a carboxylic acid, because that would have a different OH peak, you can move these double bond O's and OHs around. So there's lots of right answers. I've just drawn one, but for example, I could do the aldehyde and then put the OH here. I could move the OH to the end and put the double bond O here. As you can see, there's lots of possible answers. Now, B has to be an alkene. So we want to draw a double bond between some carbons. So if we draw the 4 carbons and put a double bond in, and then we need to get 2 O's in, and we've only got OHs in alcohols, so realistically we can just go around putting OHs anywhere on this structure. So you can just go around and put a double bond somewhere on an alkene and 2 alcohol groups on in order to meet this structure. It doesn't say anything about them not being branched, so we could branch them as well. Just make sure you've got a double bond in there and 2 OHs. Figure 2 shows the infrared spectrum of either pent-1-ene or 2-methyl-butyene. Outline how infrared spectrum could be used to determine whether the compound is pent-1-ene or 2-methyl-butyene. Now these two have the same functional groups, so actually using the fact that they've both got a C double bond C and CHs is not going to allow us to distinguish between them. We need to be using this area down here. Use the fingerprint region. So if two things have the same functional groups, we use the fingerprint region to look for an exact match on an infrared database. Fingerprint region is unique to a compound, and so would match only this one compound. Figure 3 shows the infrared spectrum of methane. Use this information from figure 3 to explain why methane acts as a greenhouse gas. So greenhouse gases are gases that absorb infrared and trap it inside the Earth's atmosphere. So we just need to be looking at why this can absorb infrared, and we've got some big peaks, so it's obvious that methane absorbs infrared. There's like a large absorption around 3,000 centimetres to the -1, and another one at around 1,200. But just to say that there's an absorption of infrared is good enough.